Hello everyone. Today we are going to start with our new topic, that is Wi-Fi 6, which is IEEE 802.11ax. Now we start with introduction. First is history. The popular wireless LAN technology is Wi-Fi. The broadband wireless connectivity is provided by it to fixed, portable and moving users in the unlicensed and 2.5 or 5 GHz frequency bands. The acceptance is rapidly gained by this technology as an alternative to a wired local area network since its deployment is much easier and more cost efficient. It becomes an everyday necessity of accessing data wirelessly for both consumers and enterprises. The entire industries fueling growth, productivity, and profits has been transformed due to unfettered access to information in the last 30 years. A key role in this transformation has been played by the Wi-Fi technology governed by IEEE 802.11 standard that provides pervasive, low-cost access to high data rate wireless connectivity to the users. This figure shows the evolution of protocols of wireless communication. This technology places its starting point in 1997 with the IEEE 802.11 protocol. The first 802.11b Wi-Fi standard that started in 1999 had a top link speed of 11 Mbps, a good first step but significantly slower than a wired connection. A few years later, the 802.11a to G revision that developed in 2003 increased the speed to 54 Mbps with the introduction of orthogonal frequency division multiplexing technology. The next link speed improvement came with 802.11n in 2009, presenting users with single stream links up to 150 Mbps. The 802.11 AC revision of the standard in 2013 brought with it the possibility of link speeds around 866 Mbps on a single spatial stream with wider channels of 160 MHz and higher modulation orders of 256 QAM. Using the specified maximum number of 8 spatial streams, it reaches its top speed of 6.97 Gbps. However, speeds approaching 7 Gbps might only be achievable in the controlled race track environment of the RF laboratory. In reality, users commonly experience frustratingly slow data traffic when trying to check their email on a public Wi-Fi at a busy airport terminal. In 2014, there was a formation of new group named HEWG, that is High Efficiency Working Group, for creating new mechanisms and amendments to IEEE 802.11, which aims to develop the new standard. Next is introduction. The next fast approaching IEEE standard is 802.11ax, by which today's biggest Wi-Fi challenges such as high density and performance can be addressed. To address this challenge, its capacity has been increased by up to 4 times and spectral efficiency has been improved for benefiting both 2.4 GHz and 5 GHz bands in a variety of environments. The client density will be handled by 802.11ax more efficiently through a new channel sharing capability. Negotiated wait time scheduling between APs and clients is used to improve the battery life to preserve energy, and efficiency improvements are delivered with at least 4 times more throughput than 802.11 AC. Next is Wi-Fi challenges. There has been an evolution of Wi-Fi with each new protocol since the commercial release of the original 802.11 wireless networking standard and achieving successively higher peak speeds theoretically. However, the speed of Wi-Fi is not the major problem in the real world, but the capacity of the network to handle the expanding population of client devices as well as numerous users with diverse networking needs. The Wi-Fi network may be designed in such a way that the growing demand for the high volume and diversity of connected devices and services can be addressed and measured on the basis of the user experience. Next is 802.11ax vision. High efficiency, high throughput, improved capacity, better coverage, reduced congestion, improved spectral efficiency. So these are the visions of 802.11ax. The 802.11ax goals: enhancement in the operation in the 2.4 GHz and 5 GHz band, increase in average throughput per station by at least 4 times in dense deployment scenarios, enhancement in both indoor and outdoor environments, maintenance or improvement of power efficiency in stations, improvement of the traffic management efficiency in a variety of environments. Next is the enhancement components of 802.11ax. First is uplink and downlink orthogonal frequency division multiple access, longer orthogonal frequency division multiplexing symbol, uplink or downlink 8x8 multi-user multiple input multiple output, spatial reuse, power saving using target wake time, 1024 quadrature amplitude modulation. New PHY headers, enhancement in the outdoor robustness, support for 5 GHz and 2.4 GHz. Next is comparison of 802.11ax, 802.11ac and 802.11n. So, second, third and fourth column represent the 802.11n, 802.11ac and 802.11ax different parameters respectively. So you can go through this table by yourself. Next is Wi-Fi use cases. For development of early 802.11ax standard, the primary use case of Wi-Fi was for high density network environments like large public venues. High density means 20 or more devices to provide an acceptable level of service to all users on the Wi-Fi network of the enterprise. It is challenging for today's enterprises to deal with corporate-owned wireless devices, employee devices, guest devices, wireless security cameras, environmental sensors, and more. Due to the potential of IoT of providing wireless access for almost everything, the complexity of these challenges has been increased. There are numerous Wi-Fi devices even within a private home that includes voice-activated smart speakers, laptops, tablets, smartphones, etc. Therefore, the home becomes a Wi-Fi hive of activity with all these connected devices. The another key use case for newer Wi-Fi technologies is the increase in the volume of streaming video. The parity must be maintained by the Wi-Fi standards with the rapidly evolving 5G cellular standards so that they remain viable users alternatively to cellular networks. The streaming video is time bounded in addition to dealing with the large data objects of the video, that is, the latency must be kept low. The dreaded buffering message or worse has been resulted by the delays in transmissions caused by the network congestion or retransmissions required by problems with prevailing radio conditions. Between 2 and 20 Mbps is required by the most of the high definition video traffic because video can be highly compressed during transmission. A bigger challenge is represented by the 4K video as Ultra HD Blu-ray runs at about 82 to 128 Mbps. Handling the growth of the WLAN will be becoming the biggest challenge with gigabits of performance instantaneously available on each Wi-Fi channel. In order to address the aggregate demand, there is a need of providing as much throughput and efficiency as possible. It is also expected that the largest market segment in wireless mesh networks is represented by 2.4 GHz devices through 2022. A new Wi-Fi standard is needed to support the expected growth of 2.4 GHz devices as well as backward compatibility with 802.11n and older Wi-Fi devices should be provided. So this is all in this lecture. Thanks.